Yeah. So, okay. All right. So, I I think I promised that the beginning of the session would be so I think I promised that the beginning of the session would be kind of for beginners. But with that said, I think I already did one yesterday. So what I want to do is I want to like ask anyone here if they kind of feel like they're struggling, if they have like specific areas that they feel they want to hear about, because there's like not very many people anyway. So I want to I don't want to like just talk to a screen again because I already did that yesterday. So does anyone have like ideas about what we should be doing about anything? So kind of absent that, like given that they promised something for beginners, I'll just do like something, but it's maybe not going to be super productive. But I'll just do something for like 10, 15 minutes, unless there's questions. I guess that's what we're doing. So I'll just sorry, keeps blinking. So Zoe, maybe you could just like log into the Zoom and then we don't have to have the screen. And yeah, 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 because like that's okay. Oh, maybe hold on. That could work.
Is anyone asking questions?
Say again?
Is anyone asking questions?
Not as far as I could see.
I'm asking questions.
Say again?
I'm gonna ask questions.
Oh, you have some. Oh, okay.
That's why I'm here.
I know some people just coming to listen. Yeah, okay, go ahead.
Can you go over the 2022 question 2?
Okay. So write the function that computes the product of. Okay, sure. What year is this?
2022.
Okay. 2022. Question 2. So this is write the function that computes the product.
I'm happy to see you.
Yeah. Of the elements of the input list.
I'm still trying to log into the game.
So that's like this. So this is gonna did you manage to log in? No?
No, I can't.
All right. What's going on?
It just didn't pop up.
Did you try pressing join?
Usually when I click on it, it just pop up.
Can you just try pressing the blue join thing?
Yes, I don't want to. Oh, okay. Right.
All right.
Okay.
Okay. All right. So yeah, so this is kind of the same pattern where we start with a result and then we keep updating it. So here, kind of what's the result that makes sense? Well, we'll see. But you do need to go through the list. And then you need to say, okay, so keep multiplying by E, right? Like so.
Yeah.
So, and then at the end, return result. So the only question here is what should the result be to start with? And the answer is, well, like it cannot be 0 because if it's 0, then it's yeah, exactly. Then it's going to keep being 0. But if you make it 1, then you multiply anything by 1 and it's still the same. So it would, so like you would be returning something like 1 times this. So that's the answer.
Okay.
right. Anything else?
This is a big question.
Mhm.
There's actually multiple parts, so let's do
Oh,
one
okay.
whole.
Okay. All right. What's the next one? Can you show me? Okay.
Oh,
So
it's for 15 parts. That's crazy.
that's like this. So what does it mean? So what we mean is that if there is like adjacent, so neighboring elements, they're the same. So if you have like whatever, like 5, 1, and then you have like 3, 3, 6, 7, then this should be true. And that's because there's like 2 elements that are equal over here, right? So on the other hand, something like duplicates like 6, 7, like this, that should be false because there's no neighboring elements that are the same. So
we just go through this.
yeah, so just to make it kind of like this, so this would also be false, even though there's 2 sexes, they're not adjacent. So that doesn't count. So that's also false, right? And that's like the usual approach, right? So just write examples, see what works. So here, what we got to do is we got to say, okay, like try all the possible locations. See if elements at location I and location I plus 1 are equal. Right, so that's kind of the plan. So all possible locations I, and then see if I and I plus 1 are equal. Right?
Yeah.
So that means that to go through the list, we need to go by location. So this would be like for I and range length list. So that's like the other way that we go through a list. And then we'll say, okay, so we'll fix it in a second, but we'll say if L at I is the same as L at I plus 1, so we found this kind of situation, then return true, because we just need to find one example to return true. Never found an example that's like that, then you return false. So one thing here is that you cannot do L at length of L minus 1 and L at length of L, because L at length of L is not a thing that exists. So you got to go up to length of L minus 1. And the logic here is that I is this, and then I is this, and so on, and then I is this. So you compare the 6 to the 7. But then like the 7, there is nothing to compare it to. So you go up to the 6, so up to the second to last one, because then you also look at its neighbor to the right.
Okay, got it.
All right. There, part C. Okay. All right. Any other requests or anything like that?
Yeah, I had a question regarding like the bonus for 2023, like the compute pi. Can you hear me?
Yeah, I working on it.
Okay.
I submitted the previous one. Yeah,
Excellent.
yeah. Yeah, that was the associate chair of research for MIE. Had to submit something to them yesterday. So, yeah, and I did. Yeah, Javier, yeah.
Wait, can you hear me?
Yeah, Javier, are you speaking? I cannot hear anything.
Yeah, I am talking.
Okay, yeah, I can hear you now.
Okay, yeah. So I had a question regarding I think the 2023 midterm. It was the bonus question
Okay.
regarding the CompuPy. I was wondering about my solution, so if I can share my screen or something like
Sure.
that.
Go ahead.
Okay.
Wait, I might need to enable it. Hold on. Uh, uh, yeah, go ahead.
Cool. Okay. Um, Can you see the code?
Uh-huh.
Yeah, so I was wondering like if this works because this is like um like when I run this, like it's not able to go up to like 1,000 because that would take a very, very long time.
I mean, the amount of time doesn't matter.
Okay, because I was wondering because the way you
Yeah, I
have
mean,
this
like you're right.
one,
Like it goes like really, really slowly. That's true.
yeah, it's just like the one that you showed in class, like had a lot of digits like printed out like after a few minutes. So I was wondering um like
Uh,
are we supposed to just continue
I don't
checking
think you're
on
doing anything differently from what I'm doing. Are you?
okay.
So let me just look. Um, I mean, oh, I see. So yeah, well, true. So when do you? Oh, you stop when term is equal to 0. Okay.
Yeah,
So
but it's not giving me like the like sometimes it's not right because I think Leibniz's formula is not like entirely like
no,
correct
no,
sometimes.
it's completely correct. It's just that it doesn't converge right away. So I wonder. So why isn't it an infinite loop anyways?
I'm doing an infinite loop because
Because
I want
because your scale is like possible. Oh, because your scale is 5. Yeah, okay, yeah.
yeah.
So no, yeah, I mean, like no. So like Leibniz's formula is completely correct. It's just that you need kind of a larger scale. Yeah, it's
Okay.
also like I think you are. So you're just stopping once the term is once like basically 2 times I is equal to scale, or like
Um
is like larger.
it's
Uh,
yeah, it's like
which is like not enough. So like you need to run it for longer. Yeah.
okay, so would you suggest like basically upping the scale like to like times 10 to 10? But then this will okay, this just
Yeah, I mean,
takes like
none
an
of it is like you're
excruciating long time.
so like you could do like that. Like if you're asking like for the purposes of this course, it's enough. So like to actually get it
Okay.
to converge, like you like there's like more that you would need to do, but like that's enough for the course. Yeah.
Okay, sounds good. Okay, thank you.
Yeah. All right. Does anyone else have like requests? All right. Let's. So I think I promised like 1 or 2 difficult prompts. I guess like let's do that now. Um. Okay. So let's see. So here we have complete the function below. So return. Yeah. Okay. Like that's well, that's like more like an intermediate one, I guess. But let's do this one. So you have a list of lists, and what you want is you want to essentially have a new list that has all the elements of all the lists of the sublists, right? So let's do this one. Oh, yeah, that's a good point. Okay, so yeah, so I'm doing this one. All right, so I want to be able to input this kind of thing. So a list of lists whose elements are like integers and strings and things like that. And then I want a flat list, meaning like not a list of lists, just a list of elements as the output. So something like this. All right. So that's kind of the same pattern again, where we start with an empty result. And then what I want to do is I want to say, okay, so like, let's go through the list of lists. So I'll say like for list 0 in list of lists. So now like list 0 is going to be the first list, the second list, the third list, and so on. And now for the list 0, I want to append every one of its elements to result. So I'll say for E in list 0, append the E to result. And that's kind of it, right? So the idea is, so let me just copy this. So E first, so list 0 first is this, and then I'm saying append the 1, append the 3, and then list 0 becomes this, and then I append the A, append the B, append the C. Okay, so same pattern where I start with from scratch, and then I kind of build it up. All right, so let's do another one. What do we have? Write code that prints all the possible 4-letter strings that can be written using A, B, C, D, E, F, G. And no letter can appear in any string more than twice. Okay, let's do that. There's a question in the chat. Okay, let me quickly answer. Sorry, yeah, I saw on my phone that you asked this on the outside, just did not get to my computer before. Will we be penalized? So first of all, the answer in general is that anything that was in class or in the lab is potentially on the midterm. And then if you want to look at what the marking scheme looks like, just look at previous year's marking schemes. So that's like the general idea. And then I'll answer your questions one by one. So will we be penalized if the answer is not as efficient? So no, on the midterm, there would not be a situation where there will be an efficiency requirement. On the exam, there might be, but if there ever is a requirement like that, it will be explicit. So there will be some kind of efficiency requirement that's in the question. Will there be any questions related to Hopfield networks? I don't know. Last year there were, and on the practice midterms there were. So, maybe. Will the questions be similar to those in the labs, or will they harder or easier? So I think if you look at previous midterms, you'll see that some of the questions are easier than what's in the lab, because like there's no point to asking a question in the lab with like a one-liner answer. But on the midterm, you might kind of start off with something easy. And then some questions, I will not say that there's no question in the lab that's like as hard as the hardest question in the midterm. I think they're about the same, but kind of how hard or easy question is, it's kind of subjective as well. So like look at past midterms and judge for yourself, I suppose. Will there be any what is the output style questions like in the year prior to 2024? I mean, that happened before. It could happen again. So, yeah. Okay. The 20. I will, but like essentially what I did is I reused the 2024 midterm as the practice midterm. So there is like just maybe like I think like I left out like 2 questions from the 2024 midterm from the practice midterm, but essentially you have it because it's just the 2024 one. It's just the practice one, yeah.
Hopfield network.
So I think like going over the Hopfield network is a little bit difficult because like it's like a whole lecture. So sorry, you were saying? Say it?
I was going to say,
Okay.
but this is not that important.
Okay. I mean, could be. So yeah, like with the Hopfield network, it really, let's kind of make a deal. So like rewatch the lecture today because I kind of feel like, like when I do the lecture, I'm kind of prepared. So like if I go over it like spontaneously, it's probably like not even as good. So like go over it again and then try to do the find the minimal whatever the minimal the energy minima, the thing that we did yesterday in office hours. And then if you're stuck on that, maybe you weren't there. Sorry, maybe it was the day before. Anyway, we also did it in lecture, right? So just kind of go over that. Try to do it yourself.
Since you have a very complicated and have multiple something. Also, what a kind of, I know it's a large belt and it's a large topic.
Yeah.
So
I mean, it's not actually that large, right? So like basically all it is you have the picture that corresponds to the energy function. And then you can basically do the one thing, which is you can look for the inputs that make the energy function as small as possible. And then in the lab, we also had kind of the learning algorithm, which was just like the English thing where like, like if xi, xj is greater than 0, then subtract 0.1. If it's smaller than 0, then add 0.1. So those are like the 3 things that we did essentially.
so like some full concept, I'll just say, answer the question.
I mean, that could help. Yeah. So again, like I'm not gonna say kind of I didn't actually write the midterm yet, so like I don't even know what's on it. But like like just like with any other example. So I think it's like it's kind of intimidating to people just because it's like it has a name, but like it's just treated like any other example. So yeah, sorry. So I was saying, so just like try to do like the example from lecture today, and then try to do it, like watch it, then do it from scratch. And then if you can do it, then great. If you get stuck, let's talk tomorrow. Yeah. Okay. All right. Sorry. So we were doing this thing. So we want basically all passwords, but like all passwords with a rule, right? So all passwords, except you're not allowed to repeat any character more than twice, is it? Yeah. Okay. All right. So first of all, how do we do all passwords? So that's a nested loop. Right? So that's like the basic nested loop. But then we only print if it doesn't violate the rule of no more than 2 of each, right? So so this, for example, should not be printed because it has like 3 Fs. So okay. So how can I do it? So what we're going to say is let's write a function. So we'll call it like valid password. And we return true if no character in S repeats more than twice. So there is like a built-in function that you can use as well for counting, but I'll do like a manual counting. Yeah. So to do the counting, I'll just say, okay, so count initially is 0, and then I'll go through every character in S, and if it's equal to C, I'll increase the count by 1. And eventually I'll return the count. Okay, so now that I have this, it's easy to write the valid password thing, because all I need to do is just go through every character in S. And if the character count is greater than 2, then it's not valid. If it is, keep checking. If it's not, sorry, keep checking. And return true if we didn't find that the password is not valid. Interesting. So, okay, there's a question in the chat. Is this also a valid solution? If I is equal to J or I is equal to K, I is equal to J, I equals L, equals K. Okay, so how many, I think it is. I wonder if you didn't miss any comparisons there. So there should be there should be 6 comparisons, I guess. And you have 4. So I think you might have missed some of the comparisons, if I'm not miscounting. So you have 4. So you compare I equals, so, oh, sorry, 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 I miscounted how many, I think. Yeah, so basically if I is, yeah, like you're definitely missing some, because here you have, oh, no, sorry, this is right. So I would be involved in everything except that J and K and L are equal. And then J is involved in 3, and then K is involved in 3, and then L is involved in 3. Okay, yeah, that's all of them. Yeah, so that could work. Yeah. So anyways, but I'm doing it my way, where I'm saying if it's valid, so we'll do like a password is C1 plus C2 plus C3 plus C4. And if it's valid, then I print. If it's not, then I don't. I have a missing if here. Have an indentation error. Valid password. Seems okay. Oh, okay. Yeah. R is not defined. Okay, sorry. Mistyping everything here. Okay. All right. So yeah, so kind of what has been suggested is, like, because there's just 4 of them, you can just kind of do the check manually. So my solution is basically to say, okay, like, first we start with the basic thing of how do we do all passwords with 4 characters. And then we say, okay, how do we check if the password is valid? And then systematically, I would say the way you would check the password is valid is you go through every character and you ask, does it repeat more than twice? And then how do you know if it repeats more than twice? Well, just write a function that counts how many times the character appears. So I think like that's like a relatively big question for the midterm, I guess. But like you start with this and then just start, like one way of doing it is just bottom up. So you just say, okay, like if I had a way of checking if the password is valid, then I would be done. And then if I have a way of counting how many characters inside a valid password, then it's kind of straightforward. So sometimes it helps to just like wish cast, right? So just like write the name of a helper function and then write the helper function. And you, yeah.
How does your function returns the result that only contains the two repeated letters?
So it says like try every character in the input.
They decided
Yeah.
to do code.
Yeah.
How the hell is it possible? Now I
Yeah.
see it.
Yeah.
Oh, okay. No, I'm confused.
All right.
Yeah, like the first one, you do the counting. Then the second one, you said if it more than that, it's a false.
Right, because like it's not a valid password if I find a character such that it appears more than twice.
So
in
you
the
say you only protect a valid password.
Yeah,
Means
so
they return true. Like, what do you mean for return true and false in this case?
okay, so like when we're thinking about the helper function, we're just thinking about like I give it an S, so like something like this. And I want it true or false, and I want it true if there are no characters that repeat more than twice. And I want it false if there are characters that repeat more than twice. Right. So I'm not thinking about anything else. I'm just thinking about like this particular string. Does it have a character that repeats more than twice or not? And then here we're saying go through every character in S. So in this case, it would be like F, F, G, E. And then if F appears more than twice, return false. If F appears more than twice, return false. If D appears more than twice, return false. If E appears more than twice, return false.
Yeah, but what does return false? Just like remove the thing from them.
It doesn't remove it, right? So this function just returns false. So over here, what we're doing is we're saying only print if valid password return true. If valid password returns false, we just don't get to this line.
Oh, okay.
Yeah.
Yeah.
All right. Cool. So we have this. Okay. All right. Do people have anything else? So I guess I can do the bonus question if people want the bonus. Sorry, hold on. Okay, so the bonus is, so it says write a function with a signature near anagram. Takes in two strings, W1 and W2, select words, and then return true if you can get W1 from W2 by rearranging the characters in W2, and then exchanging exactly one of the characters for another character. So cat and tap are, in this sense, near anagrams. Oh, wow, there's lots of stuff. What's going on here? Okay, so cat and tap are near anagrams because what you can do is you can rearrange cat to TAC and then exchange the C for the P. Okay. So that's the idea. So let's do is anagram first. So there's multiple ways of doing is anagram, I suppose. So like anagrams are like whatever, like so like Pixar and like track C are anagrams because you like rearrange the letters, right? So one thing that you can do is you can say, okay, like if I sort them, are they the same, right? So if you say like S1 is this, and then S2 is this. So you can sort strings the same way that you can sort lists. So this is like this is like this. And if they're equal, then they're anagrams. If they're not equal, then they're not anagrams, right? So you can do it like this. But that's not a super, so like that works, but that's not like super useful for near anagram. Okay. So what else can you do? You can say, okay, like the way that two words would be anagram is if they have the same number of P's and then the same number of I's and then the same number of X's and then the same number of A's and then the same number of R's and then the same number of P's, right? So it's kind of the same principle. So again, like there is actually a count, but I'll just copy my car count to here. And I'll just say, okay, like go over every letter in W1 and see whether the counts match, right? So for C, so I'll say if the lengths are different, then they're obviously not anagrams. And otherwise, just go through everything in W1. And if the counts don't match, then they're not anagrams. If you've never returned false, then you can return true. Does this make sense as an idea? So we just say, does the count for P's match? Does the count for I's match? Does the count for X's match? Does the count for A's match? And so on. So now for the bonus, you're not actually, and I should say this looks harder than it is this year because in that year we actually did is anagram in class. So the bonus like looks harder because like you've probably never seen the anagram example, except like now you have. So let's say that you know how to do the anagrams this way. So now what we got to do is we got to say, okay, like what does it take to take near anagrams? So those would be near anagrams, right? And modify this so that it kind of works. So the way it would work with near anagrams is for the letters, there would be exactly one letter where it overcounts, and there would be one letter where it undercounts, right? So, okay. So, So how are we going to do it? Again, we're going to say if those are not equal, then like there is no way that they're near anagrams because like you got to swap just the one letter. So what we now got to do is we got to just go through W1 again like this. And the only way that this would work is if there is exactly one letter in W1 where there is an undercount. And so we start with undercounts is 0 and overcounts being 0. And here we're going to say, okay, so for C in W1, again, this is like not an easy question, right? So for C in W1, there's 3 possibilities. So either there's the same number of C's in W1 and W2, or there's like one fewer in W1 than in W2, or there is one more, right? So we're going to say, okay. So count 1 is car count W1C, and count 2 is car count W2C. And now we have our 3 possibilities. So if they differ by more than 1, then that means that those are just not near anagrams because they can only differ by 1 at most. So at this point, they just differ by one way or the other. So we'll say, I'll just do it explicitly. So if count 1 minus count 2 is equal to 1, then overcounts becomes larger by 1. If count 1 minus count 2 is equal to minus 1, then undercounts is greater by 1. And that's it. So like if they match, then we don't care. So once we got here, so what can the situations be so that they're near so that they're near anagrams? So one situation would be 1 undercount, 1 overcount. So that's a near anagram. And the other situation is undercount is 1, overcount is 0. The other is overcount is 0, undercount is 1. Those are all fine. So the only situation where you actually need to return false is if both the undercounts and the overcounts is 0. And if one of them is greater than 1. Otherwise, you return true. So like that's like not a super easy question at all. Does the logic though make sense? So they're anagrams if the counts all match, and then they're near anagrams if if there is at most one undercount and at most one overcount. But that's like a bonus question, so think about it. I don't remember like many people getting it.
I'm sorry, sir. Could you
Yeah.
explain why again, if the undercount is equal to 1 and the overcount is equal to 1, that it will be true?
Well, I mean, like undercount is 1 means like there's like one extra letter in W1 that's not in W2, and overcount is the other way. So if you swap one letter for another, that's in general what would happen.
Okay. Thank you, sir.
Does that make sense?
Yeah, a little bit now.
Yeah. So like the reason you need to worry about other situations is it might be that, so like why might it be like 1 and 0? That's because it might be that you swap something in W1 for something else, and then it doesn't even appear in W1 anymore.
Okay. Thank you, sir.
Yeah.
Is it possible for us to still use like the sorted version to check if it is an anagram or not?
I mean, so you can do that for anagrams. I don't right away see, like maybe there is a way to do it for near anagrams, but I'm not sure there is like an easy way to use it for near anagrams. Like maybe there
Oh,
is,
I
but maybe I'm
see.
not seeing it.
Okay, because I was asking this because what I did was I just decided to just like if they're not anagrams, then go through every letter of the first word
Right.
and swap it with every alphabetical character until it actually is an anagram, then I would return true. Otherwise, I would
Oh
return
yeah, I
false.
think that could work. Yeah. Oh yeah. Maybe that. Yeah. I see it now. Yeah. You can do it that way. Yeah.
Okay, cool. And can we use F strings inside of like this
You can
dictionary?
use whatever you want unless it's banned, and like so like nothing except importing is going to be banned.
All right, cool. Thank you.
Yeah. All right. So I see some new people joined. So like if people have requests or anything.
Are we allowed to ask questions about Gomoku, or is that for another time?
Like if there's no like review questions, then go ahead, please. Yeah, and it doesn't seem like there's review questions, so please go ahead. Yeah.
Okay, I was just wondering for the detect row,
Mhm.
it says assume that Y start, X start is located on the edge of the board.
Yeah.
But why would we assume that in the case that like the sequence might not actually be on the edge?
So like the distinction is between sequence and row, right? So row is like the whole 8 squares, and the whole 8 squares has got to start on the edge, but the sequence would be inside the 8 squares. So like detect row takes the whole, like the location, like it's either the whole row, the whole column, or the whole diagonal. Not necessarily 8 because diagonals can be shorter, right? But a sequence is like a sequence of 3 stones inside of the row or column or diagonal.
Yeah.
Does
Okay,
that?
so then within that row, we're basically just looking to see if there's a sequence and whether it's
That's
open
right.
or
Yeah,
whether
yeah,
it's
yeah,
closed.
exactly. So the row starts at the edge. The sequence is like inside the row, so not necessarily at all.
Yeah. And then so then as part of that, we would also have to check that it's actually a complete sequence because we can't just assume that.
Well, so like the complete sequence thing is yeah, so like only complete sequences count. So like if you're being asked about sequences of length 3, then if all you have is like actually 4 stones in a row, then it's 0 sequences of length 3 because incomplete sequences do not count as sequences.
Yeah. Okay, thank you.
Mhm.
Regarding that, I was wondering when like the grade scope will be updated to have
Yeah, so I will update it tonight, but I'm not gonna put out any new test cases. So like the test cases are just gonna be what's already given to you.
Okay, cool.
I think I have created another infinite loop.
All right.
Can you please check my code? I feel like it did something wrong. It it just kept this thing.
No, but like it's like waiting for the input, right?
No, I input something and
It doesn't look that way. Oh, I see. Oh yeah, you're right. Yeah, so that is actually an infinite loop because you're saying while user input is not. So if user input here is not exactly this,
yeah.
then it's just going to count forever. So like you really mean like if.
If I change to this with this hosting word.
Well, I mean, then it would return the count, right? So what you really probably want is you want for the input. So for line, what line is it? For line 30 to be inside the while loop, right?
Line 30
Yeah, because like you want to repeatedly,
ask
right. So that means that you want to get the input inside of the loop.
But if I put while but I want to put I need to set up a condition for a while. Like when the while should stop.
Well, yeah. So this is a situation we also had in lecture, right? So like, well, I think the issue that you are having here is that you want the user input to be something initially, but you don't know what it is, right? So the only kind of solution in that case would actually be to get the user input outside the while loop once, and then keep getting it inside the while loop as well. So just like call the input function twice, once before the while loop and once inside the while loop.
Let me see. I'm gonna test this one in order to use. How do I test this? Do I just keep doing like what I like keep just repeating this and doing? But there are not
Yeah,
even-
so
there's-
here, like the user input here, you don't really know what the user input is, right?
Yeah.
Sorry, so let me like not abandon the people in Zoom. People in Zoom do you feel like lonely? Do you have questions?
I guess like this is unrelated a little bit.
Okay. Sorry, I can
Okay,
barely.
'cause-
So like, if it's gonna be a long question, I'm gonna plug in my headphone for a second. Sorry, just 1 second, because like I can like barely hear the speakers. Yeah, go ahead, please.
Okay, so I think like on Friday or something like that, you mentioned
It's interesting. Yeah, go ahead.
you mentioned like the Pong game or
Yeah.
the tournament. So I was wondering like because based on the description, I was just a bit confused as to how the like first place, second place, third place, like how is that gonna work? So
I mean,
are we just
like-
all playing against the chaser?
No, that's like the qualifier. So what they do, so what they'll do is I'll run every submission against the chaser. And that's just like in the interest of time, so that like if someone doesn't win against the chaser, then they're like excluded from the second round. And then everyone whose code runs and wins against the chaser just plays a round robin. So everyone plays against everyone, and then whoever wins the most games is in first place.
Okay, so like the 0.5 is like once you're qualified, then you have 0.5, basically, right? 'Cause-
Yeah, that's exactly right. Yeah.
Okay, and so therefore, like basically, like, is the tournament going to be run by like just changing the code where it's like user input and changing that to like our AI basically, and then like
That's basically right. Yeah. So
okay,
I
and
mean,
how do
like,
we?
not like literally that. So like I have like my backend code that's like a little bit more efficient than that, but basically, yeah.
Okay, but like the logic is going to stay the
Yeah,
same.
yeah, the logic, yeah.
Okay, and like, how are we supposed to submit this? Is this like,
Like on
because I see
Gradescope, like
it's
there's gonna be a place on Gradescope to submit.
okay, and like, when are we going to be doing the tournament? Is it like,
Oh,
I mean, it's due December 4th, so some days, like a few days after that, I'll run it and like announce the results.
okay, cool, thank you.
Yeah. Yeah, yeah. So that was about the Pong tournament, and like it was like about the logistics. And the answer is it's going to be a round robin, and like whoever submits on December 4th, there's going to be a round robin tournament. So yeah. All right. Sorry. Okay. Is there any more Zoom questions?
Uh, yeah, I had a question. So I was looking at the syllabus and there were like 2% online exercises.
That's
and
right.
it's
Yeah. So we haven't posted those yet. So like the kind of those are going to be like small ones that are going to be posted. Yeah.
all right, thank you.
Yeah. All right. Okay. All right. Last call for Zoom questions, and then I'll do like an in-person question.
Wait, sorry, like I have a question.
Mhm.
So for the assignment, are we supposed to write something to prevent the user from enter the
No. So no. So like all that you're required to do is just the functions that are in the handout. The interaction with the user is not part of the assignment. So like you can use it to just like play against your code if you want, but it's not part of the assignment.
Okay, thank you.
Mhm. All right. Okay. If there's not any more questions, I'll close the Zoom session. All right. See ya. Bye.